In this video, we're going to look over linear approximations and differentials. So for linear approximations, say I have this function f of x right here, and I have the x value a. So if I plug in x value a into f of x, I will get f of a. It's right here. But say I want to find b and f of b. So we can use an approximation. We can do an approximation using the tangent line right here. And if we go up here to the tangent line, we see that this point b is pretty close to this point here that's actually on f of x. But say we want to do c. We see that this will not be accurate if we go up to the tangent line, because then this f of x line is all the way up here. So approximation only really works if you have an estimate that is already close to the point you're trying to find. So how do we actually do approximation? Approximation uses the tangent line. So we're going to use the slope, point slope formula. It's going to be y equals y minus y1 equals m x minus x1. But we have a different version that we're going to use. So you know that a is an x value. So x1 is going to be replaced with a. So it's going to be x minus a. And we know that y1 is f of a. So it's going to be y minus f of a. And what is the slope? Well, the slope of the line is a derivative. So m is going to equal f prime of x. And if we rearrange this, we're going to get y equals f of prime of x times x minus a plus f of a. And with this, we can start finding approximations. All right, let's do an example. So let's say we have f of x is x to the x cubed, and then our a value is 2. And we're trying to estimate f of 2.1. So that's going to be our b right here. Now obviously this will be really hard to do in our head, so we're going to go use a linear approximation. So we're going to use this formula. So first we need to find f prime of x, which is going to be f prime of x equals 3x squared. Okay. So now we can start plugging things in. So f prime of x is going to be, Alright, so we're going to plug in a into f prime. It's going to be 3, 2 squared. I'm going to do x minus a, so x minus 2 plus f of a, which is a cubed, so it's going to be 2 cubed. So here, we can do this right here. It's going to be 2 squared, which is 4 times 3, which is 12. X minus 2 plus 2 cubed, which is going to be 8. Now we can distribute this 12. It's going to be 12x minus 24 plus 8. Now we can combine like terms. 12x minus 16. Okay. This will equal our y. So now we can, so this will equal our L of x, which is our approximation, L of x. Now we're trying to approximate 2.1, so we're going to plug in 2.1 for the x. It's going to be L 2.1 equals 12 times 2.1 minus 16. Alright. So here we can do this math. It's going to be, so 12 times 2 is, alright, so we have 24 plus 1.2 minus 16, so we can combine 24 minus 16, which is going to be 8, then add 1.2, it's going to be 9.2. So we have figured out that f of 2.1 is approximately 9.2. And if you put that into the calculator to confirm, f of x was x cubed, so 2.1 cubed is going to give us 9.261. So we were relatively close. Let's move on to differentials. So say we have y equals f of x. Pretty typical. Say we want the derivative of that. So that's the derivative. It's going to be dy dx equals f prime of x. Now, what if we multiply both sides by dx? These cancel. So now we're left with dy f prime of x dx. Now, this is the fundamentals of differentials. You're going to use equations similar to this a lot when finding differentials. That's basically how you set it up. Now, what does dy and dx mean? Dy is approximately equal to the change in y, which is just y2 minus y1, the change in the y values that you have, similar to what we were doing with the linear approximations. Now, the change in x is going to be dx. So dx is equal to, it's not approximately, it's equal to delta x, which is just x2 minus x1. Alright, now let's do an example setting up a differential. So say we have y equals x to the 6th power plus 7x squared plus 3x. So let's find the differential of that. We can start by just taking the derivative. So it's going to be dy dx equals 6x to the 5th plus 14x plus 3. Now we do the multiplication of the dx, which is going to be dy equals 6x fifths plus 14x plus 3 in brackets dx. And that is how you set that differential up.